My name's Stuart Harris, one of the founders of Red Badger. I'm standing in for a talk that's actually been postponed to next month, so we'll have to wait for that. It's quite an exciting talk about Reflex, which is the framework we're building for isomorphic applications. The repo is public, but it's not published to NPM yet. There's a few things we want to do before we do that, including finishing off the documentation. So we're going to push the NPM publish button at next month's React Meetup, and the talk that I'm standing in for is going to be all about that next month. So I thought what I'd do, I was reading back through some of the feedback that you've been given, so thank you very much for all the feedback. It's been really useful. But one of the things that kept cropping up quite a bit was we want to see more examples of React being used in the real world for big, large-scale applications. So I'm going to do a quick show and tell. Unfortunately, the title's a little bit on this slide is a little bit misleading because I didn't have time to seek out the permission to talk about what we're doing right now with Tesco, but what I thought we could talk about was stuff that's already out there, stuff that's in the public domain already. So I just wanted to talk briefly a little bit about how we've built first the international grocery home shopping sites for Tesco. So this is something that started almost exactly a year ago and went live in January in 8 countries. So that's the Thailand site, I think, in Thai, that you can see there. But we'll look at it in a little bit more detail. So first of all, a little bit about Tesco and about React. Tesco is the world's 3rd largest retailer, and half of the world's online grocery shopping is done with Tesco. So quite a large volume, especially in the UK. So we're better at online grocery shopping than anywhere else in the world. I think that's fair to say. But what I'm going to talk tonight about is about the international sites. But React has transformed user interface engineering at Tesco, without a doubt, and helped them build large-scale isomorphic applications that are fast to run and quick to build, easy to maintain, very flexible, very adaptable, and have so far been great. And they've got a whole bunch of great designers and great user experience consultants, people working at Tesco, and they want to get that great user experience to the hands of the customers. So it's really important that the technology that's chosen is able to do that. And as we've heard from Jonas's talk and from other things that we've been seeing about isomorphic applications, that is the way right now to deliver a great experience. So we built, the team at Tesco have built international sites for Poland, Hungary, Czech Republic, Slovakia, Turkey, and Malaysia and Thailand. And it's quite a lot of different things. It's a multi-tenanted site, but each tenant is quite different from the others, or some, the brand is different, language is obviously different. So each country has a choice of English or local language, and currency is different, and some currency formatting, number formats, all the locale stuff, time zones different. And also each country has individual features which need to be switched on in this country or switched off in that country. Like in Poland, if you want to buy alcohol, you have to accept the fact that you're over 18. Actually, that's not, I suppose they've already accepted that fact. But, and there are different legal requirements and different features that need to be switched on and off. So a year ago, we decided to build with Tesco an isomorphic application for this. It was really important. We've talked about the benefits of isomorphic applications, and we've talked about how they're great for SEO, and they're great for accessibility, and they're great for fast first page load. And the non-JavaScript part of this is actually quite important for Tesco. It's not important for a lot of people, right? Almost every user has JavaScript turned on. And if you're behind a login wall, then it doesn't matter about SEO, it doesn't matter about non-JavaScript for search engines because they can't get behind the login wall anyway. But for Tesco, it's quite important. You know, all that content needs to be indexed in Google and all the other search engines, especially you know, in Asia. So non-JavaScript is really important. It's only like, I don't know, 1/4 or 0.5% or some ridiculous small number. But that still represents quite a large revenue stream when the numbers are multiplied up. So one of the overriding factors in this is that it has to work without JavaScript. So that doesn't mean that we need a full fidelity experience with JavaScript. And the initial brief was to be able to complete the journey if you haven't got JavaScript turned on. As it happens, you can't tell the difference. So with React Isomorphic, you turn JavaScript off, you just carry on as normal. In fact, one of the things that we found was that on mobile devices that have really old, I say really old, JavaScript engines, we're only going back like 4 or 5 years, right? So 4 or 5 years ago, JavaScript engines were slow. And we forget how slow they were. And especially on mobile devices. So, you know, if you want that fast first page load, loading your whole application, parsing all that JavaScript, it's not the download time that's the problem. It's parsing the JavaScript and getting your application up and running is prohibitively slow on old mobile devices. So we discovered that if we do some user agent sniffing, we can turn JavaScript off, or actually not even turn it off, it's still running on the client, but we just don't deliver any JavaScript. So if you've got an old, I don't know, iPhone 4 or something like that, and you try and access the site, you'll get a great experience, but it won't be JavaScript enhanced. So it'll just be like the old days of the web when everything's request response and you just go through the normal journey as is. So quite interesting, because when you think about JavaScript and progressive enhancement, you think that, you know, your application works with HTML and CSS and JavaScript enhances the experience. But if you've got a really, really old JavaScript engine, it might actually detract from the experience, and turning it off or not even delivering it at all gives you a much faster experience, and it goes bash, bosh, 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 bosh all the way through, whereas it doesn't necessarily, you know, it takes a long time to get that JavaScript up and running, and you might not have the memory to do it anyway. So, a year ago, there weren't very many patterns for building isomorphic applications as Jonas described, and those sort of patterns are emerging now, but there wasn't anything. So I was talking about April 2014, Flux didn't even exist, right? So it was just React. We'd already used React for the Hala Foundation app, which was client-side only, talking to an API. So that didn't help us with the isomorphic thing, but it, you know, gave us a bit of React experience. But and so it was quite a tough challenge to work out how to do a big, complex application as a fully isomorphic app a year ago. So we decided that we would divide the problem up into smaller chunks, and we built multiple isomorphic single-page applications, but presented them as one. So what I mean by that is that you load a page, it doesn't matter which page it is in the application, or whatever route, any URL, it renders first on the server. And then you may carry on client-side for a little bit. But if you move to a different part of the application, then you'll load a new page from the server. And then you may carry on client-side a little bit longer, and then you may jump to another page. So that was the technique that we used, like a divide and conquer sort of thing. And that has like loads of benefits, but also has a few little problems which we'll talk about. But one of the benefits is that when you jump to a new page, you can download in the page most of the data you're going to, if not all the data you're going to need. And so your dependency on Ajax and client-side patterns like flux disappears a little bit. So remember, we're pre-flux at this point. So anyway, so let's have a look at this thing. There's, how do I do this? So this is, I'm just going to show it to you in this, because I haven't got a mobile device hooked up to a camera or anything like fancy like that. But that's the Polish site, and that's the Thai one we looked at earlier in Thai, and the Turkish site in Turkey. They all have a switch to English button, right? So, but we'll use the Turkey one, sorry, the Polish one. So the first thing to note, this is the home page. So the first thing to notice is that on the right-hand side, wait, I don't know if you can see it, read that HTML. Shall I make this a bit bigger? Oops. Does that help? So Jonas talked about embedding the data that you want to send down for the first page render on the client as a script tag with type application JSON. We had quite a strict content security policy. I think we didn't realize at the time that even if you said that you can't load inline script, if you've got a type application JSON, that's still fine with this content security policy. So some of the newer applications have the data as a script tag, just like Jonas described. But what we did here was stick it into data attributes on the document element. So we thought that was a bit weird to start with, because like if you've got a ton of data, what does that look like when it's serialized into a single data attribute? And the answer is, doesn't matter. You can stick, the HTML standard says that the attribute name can be as long as you like, and the content can be as long as you like. So, and we haven't found a single problem with the length, with the size of the attribute content. So on this page, for instance, we've got some data in the page, some data alternate languages, Poland, and then there's a bunch of some assets that need to be specified, some configuration that the client needs, some Google Tag Manager stuff, some translations, so we can do all the translation stuff, etc., including all the data for the application. So all the props effectively for the component are sent down to the page. It's really important when you're doing isomorphic applications is that it gets exactly the same environment to render in on the client as it had on the server. So we took this approach. So let's just have a look at this application. So first thing to notice is that that was a page load. You can see on the right when the page loads, right? But now we're going off client side, and the URL's changing, and we can use the back button, but that's using push state, and this browsing the site is a single page application, and obviously the browser back button works. So if I then click onto one of those, now we've just loaded another page. So now these search results is another page, and the data for all that all those products is there in the data attributes. I guess it's more efficient to send it down as in a script tag, because it doesn't have to be encoded. So the browser's not it's decoded already before it's shown it to us, but in the actual payload, it's been encoded, so you've got like lots of percent values in there, so it makes it a little bit bigger. It'll compress really well. If you've got gzip on, it's absolutely fine. It's not really a problem, but probably more efficient to send it in as a script tag. So if I want to buy something, then just log in. My name's Emily. Oh, I should click this. And it's in my basket now, and I can add some more. And we do use some Ajax, obviously, but because we're jumping from page to page, it's less. We've got less need to use Ajax, because it's just really for where we can enhance the experience. One of the first things you should do, actually, probably before you put stuff into your basket when you're doing grocery shopping, is book a slot, because you probably want to book a slot now before they all go, especially when it's near Christmas, and maybe we want click and collect instead of home delivery, and maybe we want to change the store. Maybe we don't actually. So this is another client-side application, so I can move between different slot dates, and it's all client-side, and I can use the back button to go back between them. But when I actually book a slot, I'll move me to another page, some notes in, and check out. And then when I check out, I can either pay online. Notice the URL is still changing, so even this is a single page application where the back button and forward button. And if I want to place the order, actually just place this order on the live site. So somebody in Poland is going to get some potatoes. So what we should do is probably got my orders placed there on the home page, and I've got my order history here, and I can see that I've got this order which I can cancel, or I can make changes to. These are all the previous orders that we've cancelled on this account, so it's probably messing up the analytics like crazy. That was my trolley, and I can either continue shopping. Now I'm in amend order mode, and there's the order cancel changes and save changes at the bottom. I can just continue shopping. I'm still in amend order mode, so I can add one of these things, actually more jelly potatoes, and then when I've finished, I can save those changes, confirm the difference, and bingo, job done. I'm actually going to cancel it because I don't want those delivered. Well, something went wrong. Okay, back to the demo. Typical live demos. Right. So the journey that we took. This was pre-Flux initially when we started it. So we were using set state, and when you're building big applications, it takes quite a lot of courage to use set state everywhere, and then it gets quite messy somewhere. In May, I think, there was a blog post that announced Flux, and I think it was probably June when it actually started to appear, really. And then so we built our own implementation of Flux, or we used an implementation that we built ourselves based on the pattern. And then later on in the year, we started converting to Facebook's implementation, I think probably early this year, actually. So we've had a little journey with Flux, and we've moved from sort of like not using it properly to using it properly. We've also started using immutable data in a lot of stuff, and we are testing out cursors over immutable data with global application state, and that's what the Reflex talk is all about next month that this is replacing. And obviously we want to go to Relay and GraphQL when that comes out, because that looks really good. And there's a blog post on Relay on the React blog, if you haven't read it, a few days ago, really good read. And I think that because that uses sort of like a global store, and I think that global application state and immutable data, all the UI frameworks are going to immutable and getting massive performance increases because of it. And I think that the future is going to be some kind of balance between global immutable application state using cursors and Relay and GraphQL obviously going in that direction. So that's the journey that we're going on. But we're sort of around about 4 and 5 at the moment. We are using Reflex at another big client, so we're giving it a bit of a test run. It's quite exciting. But we talked about some of the problems of multiple pages rather than one big single page. So they're small, each page is smaller, and they've got contained state. You can think about just that page as an application, which is actually quite nice. You don't have to worry about the rest of your application. You don't care about it. It's on a different page, right? So it's easy to reason about. You've got less risk of memory leaks because the page is being refreshed all the time. Like, memory leaks on the client haven't been a problem, but you could get them, right? If you've got a long-living application on the client, you could imagine that over time it could chomp up some memory, and you never know what's going on. If you're moving pages all the time, it's not going to happen. There's less need for AJAX because the chances are you've got the data that you want that was delivered to you in the page. But they are less interactive because when you move to another page, you've got a page refresh. So modern browsers are quite good at that, and it's not too bad, but it can be a bit of a problem. And also, config and translations is a bit of an issue because you've got to send down all the config that you need for the client to render and all the translations that you need and basically all the props, everything the component needs. And understanding from the server-side render what that is actually quite important to do. So we'll have a look at that in a bit more detail in a second. So this is our stack. We started off using LiveScript. You probably know we did some talks about it before. LiveScript is a compiled to JavaScript language. It's not CoffeeScript. CoffeeScript has lots of problems. LiveScript doesn't. And LiveScript's brilliant because it's influenced by all these functional languages like Haskell and F# and stuff. And there's built-in language constructs for currying and for piping and all sorts of cool things. It's great, LiveScript, but we've moved most of the application, or a lot of the application to ES6 and JSX because we want to be in the mainstream with this, and we want to make sure that upcoming versions of React, like 0.13 and stuff, we can use all of the ES6 class constructs and all that sort of stuff. So we're using ES6 with Babel. If you haven't used Babel, it's absolutely brilliant. Compiles your ES6 to ES5. It's even got an experimental mode that you can use some of the ES7 features, like async and await. Absolutely brilliant. So we started, next bit of the stack, we started in React 0.10, we went to 0.11, we went to 12.12. We're on 12.2 at the moment, and we're moving to 13.1 as we speak, but it's, we have to keep the application up to date as much as we can all the time, and it's a big application that can filter all the way through, and it's quite difficult to make sure everything's right. We started off with homegrown Flux. We're now on 2.01. We've got immutable.js in there. The router, the client-side router is page.js at the moment, but in other projects we've been using React Router. We did flirt with mono router temporarily, but routing is a bit of an issue, I think. Probably everybody agrees it's not straightforward. Routing on the client is a very different concern to routing on the server, all sorts of different things you need to consider, and it's a different thing altogether, right? On the client, you're just changing state and changing the URL in the browser. On the server, all sorts of things could happen, and it's very different. You've got to do some rendering, generate some HTML, send it to the client. We started off with Browsify. We're now using Webpack. We've got component hot loading in there as well, so which Webpack gives you, which is awesome. So as soon as you press save in Atom, not Sublime Text, doesn't work with Sublime Text. No, it does. When you press save, then the component hot loads, and that's brilliant because if you've got state in your application, so you've navigated to a certain part of your application, you've keyed in some data, whatever you've got, you scroll to a certain part, and you want to just change that component, then having that component change when you press save in your editor without having to reset up the application client is absolutely brilliant. So the hot loading is really important. For translations, we started with the I18 Next, and now we're using Node Polyglot, which is the Airbnb thing, and it's really good. We started with Mikhail's request, then we went to Super Agent, now we're on Fetch. Testing, we started off with Jest, but we didn't like the auto-mocking so much, and we wanted a bit more control, so we used Jasmine, test utils, and JSDOM on some projects, Cheerio. We started off with Cucumber.js and a JavaScript stack for outside-in testing, and now using Ruby and Cucumber and Capybara and stuff with Ruby. So I guess the point I'm trying to make in this is that nothing has to stay. When you start a project, you don't have to finish the project necessarily with the same tools, and you can migrate those tools as you go. And it's important to do that. It's important to keep the application up to date all the time. Some code. Right, so hold your hats, because some of this is going to be live script, some of it's going to be S6, some of it's going to be make sense, some of it isn't going to make sense, some of you think, oh, that could be done better, or whatever. Some of it's a year old. But we're just using Express on the server, right? So this route gets some data, and then it renders. Okay, that wasn't a good one. This is a good one. Response.render, and then the name of a React component. So that's quite Express-like. Can't really see it, can you? So that's quite Express-like in the sense that you know, if you were using a templating language like Jade or something on the server, that's how you do it. So in order to do that, we wrote a little React view engine, which we talked about before, which literally just plugs into Express. And here it calls components.render. Components is this thing, which has got a render method, and it's either client-side or server-side. So this, in the whole application, this is probably the only part of the application that does something different depending on whether it's on the client or the server. When it's client-side, it does React.render, and when it's server-side, it does React.render to string. But it uses this app component, which is, you know, is like the parent of all components, and renders the relevant component. So we've basically fetched all the routes, fetched all the data, stuck it onto the locals. It's effectively a bit like rendering with Jade, but we're rendering with React instead. One of the downsides to this multiple page thing, so these are all the pages in the app. You can see there's quite a few of them, 30 or so. You have to, one of the downsides is you have to actually explicitly mention every single one, otherwise it won't get packed up, because obviously Webpack and Browserify use static analysis to work out what components to bundle. This is a typical JSX component written in ES6 and JSX, nothing very exciting about it at all. And this is a typical LiveScript component, and here's some client-side routing using Page. One of the great things about Page is that it's really simple and self-contained. It's like a mini Express on the client. The routing is exactly the same. The route's expressed in exactly the same way. It's quite easy. So I think now we would probably use React Router and do that isomorphically, but then this is what we used. But one of the downsides to rendering on the server is all the translations and configs and stuff. So if the server is rendering a specific route, then we anything that happens on the server, every time we reference a translation or reference some config, it automatically gets slapped into the document page. But there may be other routes that the server's not rendering. The client will render later, and when it gets to those routes, it's not going to have the relevant props that it needs, or the config or the translations for those pages. So this is like preloading some stuff that we know we're going to need. Anyway, so there are a lot of better ways of doing this, but a year ago, that's what we did. And you know, there's lots of streams of updating going on within the project to bring all those things up to date quickly. So, what have we learned? We learned that we don't need to deliver JavaScript to old engines. We talked about that. That's great. Quite cool. So, don't have a global dispatcher. So the Flux pattern is global, and you talked about this earlier. And the solution which would work well is to have a reset on your stores and all that sort of stuff, so that you can clear the data down. And as long as you do everything synchronously, you'll be fine with that. We have our dispatcher passed down in the context. So we render with context, and we just pass the dispatcher down in the context to all the components. And the root component will create the stores. So the stores and the dispatcher, instead of being global on the client or the server, are both. On the server, they're request lifetime. So they get created when we start rendering, and they get destroy when the request is finished. And on the client side, they're long-lived because the components are long-lived. But they're effectively scoped to the root component rather than to the page. We've learned that we should write smaller and more focused components because that's what components are all about, right? But some of our components tended to be bigger than they should be, and that's possibly to do with the fact that we were using LiveScript originally, because in LiveScript, it just looks so neat, and because you've got much less in the way, you tend to write longer stuff because it just reads so well, and it's all in line as well, so you're not referencing stuff that's up the page somewhere, so it's actually reads better as a long component. But with ES6 and JSX, that doesn't work so well, so much smaller components, much more focused, and more use of context too. Didn't finish that slide. Anyway. So, where to now? We're moving towards single-page isomorphic applications. So the multiple-page stuff will eventually disappear. Those multiple pages we're sort of like bringing into one and making them bigger, and introducing new patterns to do that. Wrapping containers, components and containers for increased portability. So Rob talked about that. That's in Relay. The inner component is completely portable because it doesn't depend on anything other than its defined prop types, and the outer container does all of the environmental stuff to satisfy the needs of that internal component. And I'll skip the next one for a second. Continuous delivery using Docker containers. So this is the same principle as that, but on a in your machine sort of scale. Your application runs inside a Docker container, and the Docker container provides all the environmental stuff for your application, in the same way that these component wrappers provide the environmental stuff for the inner component. So, two different scales, but the same principle. The one I missed out: component composition use component composition over mixins. Mixins are obviously going to go. I like mixins, but they're not the root of all evil, right? But they are a form of multiple inheritance, and you get clashes, and it's not always clear what's going on or why something's happening because you're not quite sure which mixin it's come from, and I guess behavior could be unpredictable, but they are quite useful for some use cases, and I think over time we're trying to deprecate our use of mixins as much as we can and use other techniques instead. We're hoping to share parts of the application with React Native apps as we build those as well. So I think that's it. Any questions?
Sorry, perhaps the one part of your stack that you didn't talk about was styling. Could you
what, sorry?
Styling.
Styling. Yeah, that's a good point, actually. So we use less initially and Sass. We try and keep the styles in the folder of the component itself, so they're local to the component, so they're close by. Started to do some inline styling as per React Native, and Christopher Shadow's talk about inline styling. I quite like the idea of that. We haven't really got very far with it yet, I don't think. But just regular Sass. And less.
Hi. So as a web person, I understand that it's nice to have isomorphic applications, and it's good for when you hit a website with curl to get back something which isn't broken. I guess with all of the data activity in the W3C, with kind of standards for embedding data and web crawlers nowadays looking for data as opposed to HTML, should we care about isomorphic web applications? Is there even, both you and Jonas talked about SEO being something there. That's probably, search engines probably don't look for HTML anymore. And if they do, they probably penalize you if your data is not kind of in a nice format. Should we care about isomorphic web applications?
Yeah, really good question, actually. I think we should, obviously. So Google only announced sort of May, June last year or whatever that they were starting to use JavaScript in web pages, but they haven't said how or why. I don't really understand how much JavaScript is actually going to run and how far it's going to get through your application client side, and I don't know how long it's going to go before it gives up, or has it gone around in a circle? I don't know. Like, nobody's really talked about what they're doing, and no other search engine has done it, right? There are other search engines as well. So I think for SEO, it's still quite important. You mentioned data formats and microformats and all that sort of stuff, and JSON-LD in JSON in a document. We're starting to do some of that, and Tesco's starting to put JSON-LD into the page. Yeah, for SEO, it's actually massively important, and Google announced recently they're supporting JSON-LD now, which is great. So I think there are ways around it. I think from a usability perspective, that first page load is crucial. Like, if you just jump into an application, you want it fast. You don't want to have to boot it all up and build your DOM client side and go and fetch the data you want. So I think it's important.
Hi.
Nice.
Great talk.
Thank you.
I especially enjoyed the bit at the beginning, which my question relates to, but it's also related to this. Your previous question, which you missed out in the answers to, was that it's some of your clients can't even handle the load of the application, right?
Yeah.
So in Tesco, for instance, with hundreds of millions, if not billions of clients, some of them are on feature phones that can't even handle the application state via JavaScript. So you kind of always have to have the fallback. It's not all about SEO, it's about progressive enhancement. That's my own opinion. So my question related to that was, I found it really interesting that you mentioned how to get around that problem, you use UA sniffing to essentially turn off the JavaScript or just not deliver the JavaScript. Do you do that in terms of device categorization via, so obviously you do that on the server side, you have some kind of device library looking up against a user agent. Do you categorize via device, or do you categorize via feature of that device? So you're doing feature detection, or are you doing device detection?
I think feature detection is much better if you can do it, but is there a feature for like shitty JavaScript engine, like rubbish JavaScript engine? I don't know. I mean, like how? I mean, we did think about measuring the speed of it at some point, and then determining, inventing our own feature detection. Like, how long does it take to, add up 100 numbers or something? I don't know. Just to work out whether it's too slow, is it above or below a certain threshold. But in the end, we decided that it only affected, it is quite easy using user agent sniffing to work out if you're on an iPhone 4 or an old Android or something. So it wasn't really a problem. Yeah. It's actually quite interesting that so one part of the demo that you're right, I did miss out, was that like when you turn JavaScript off, let's turn this back to English. The experience is exactly the same. So if I turn JavaScript off, click Browse the Store. So this was client side before, but now it's server side. So the page is refreshing on every click, but the experience is exactly the same, right? And that's worth its weight in gold.
Yeah. So interestingly, I've had exactly the same problem, but we approached it via feature detection on the client. And you're right, there is no JavaScript method for is old JS engine. So we decided to choose random bits of the JavaScript spec that we weren't necessarily using, but we knew the class that we were aiming to avoid didn't have. And so
I like that.
It's the BBC News' cutting the mustard approach, but taking it one step further of just ISO. And then as we had, the more that our stats progress and those iPhones drop out, then we can just add in a new feature to that test so that we isolate those and they just get a streamlined experience.
Exactly. Yeah, so we've got it cuts the mustard middleware, that's what's cool, and it does a bunch of different things, but that sounds like quite a good idea to do that. Brilliant. Don't anybody ask me a question I'm not allowed to answer, please.
Hiya. So in one of the slides you mentioned that you switched from using Cucumber.js to Cucumber and Capybara. I guess everyone's now using Node and JavaScript and things. Why have you switched from using a JavaScript-based language to a Ruby-based language?
That's a really good question. Rob is laughing here. It was because that's what most of the testers that are doing automation testing wanted to do. Simple as that. I don't think it matters one way or the other. We chose Cucumber.js to start with because we're JavaScript programmers and that's familiar with us. And to your point, that's exactly, seemed like a logical thing to do. But I think it's fair to say that most automation testers are writing Ruby these days. So let's go with the flow. No other reason, really. I mean, Cucumber.js worked brilliantly well for us, and it's a difficult thing to do, right? With working with Selenium and all that sort of stuff. It's not without its problems, and the value of that sort of testing is in question in some circles anyway, and maybe the tests aren't as valuable as we think they are. So, yeah, we just switched. Anyone else? No? Good. Brilliant. Thank you very much. Okay, thank you ever so much for coming. We'll announce the date of the next one. I'm not sure when it's going to be, but it'll be about a month's time. So, thank you. Oh, and thank you, Facebook.